Assalamualaikum and good day everyone. Today our group will be presenting on acid-base titration in everyday products, specifically vinegar, antacids and beverage. So, what is acid-base titration? Acid-base titration is a method used to determine the concentration of an acidic or basic solution. In this process, the solution with an unknown concentration is called the analyte, while the solution with a known concentration is called the titrant. The principle behind this process is known as neutralization, where an acid reacts with a base to produce salt and water. The general equation for this reaction is acid plus base gives salt plus water. Acid-base titration is important because it helps determine the exact concentration of solutions. It is also widely used in pharmaceutical quality control to ensure medicines contains the correct amount of active ingredients and maintain the proper pH. In addition, the food and beverage industry uses titration to monitor acidity and ensure product quality and safety. Now, let us look at the common apparatus used in acid-base titration. The first apparatus is the burette. It is used to accurately deliver the titrant and allows precise measurement of volume added during the titration process. The second apparatus is the pipette, which is used to measure and transfer a fixed volume of a solution accurately. Lastly, the conical flask is used to hold and mix the analyte solution throughout the titration. Its shape allows the solution to be swirled easily without spilling. These apparatus are essential for obtaining accurate and reliable titration results. Next, we investigated several everyday products that involve acid-base titration. The first product is vinegar. Vinegar contains acetic acid and is commonly used in cooking and food preservation. Acid-base titration can be used to determine its acidity level. The second product is antacid. Antacid contains basic compounds such as calcium carbonate and are used to neutralize excess stomach acid. Titration helps measure their acid neutralizing capacity and ensure their effectiveness. Lastly, beverage, including soft drinks and fruit juice, contain organic acids such as citric acid and phosphoric acid. Acid-base titration is used to determine their acid content and maintain product quality.
Let's move on to our first real-life application, which is the determination of acetic acid in vinegar. Firstly, why do we need to test vinegar acidity? This is crucial for industrial quality control and regulatory compliance. In Malaysia, under the Food Regulations 1985 from Kementerian Kesihatan Malaysia, commercial vinegar is required to contain a minimum of 4% acetic acid. Testing ensures the product is safe for consumers, maintains its shelf life as a natural preservative, and keeps the taste profile consistent across all batches. For the theory, this analysis is based on a neutralization reaction where acetic acid, which is a weak monophotic acid, reacts with sodium hydroxide, a standard strong base. As you can see on the slide, the chemical equation shows that 1 mole of acetic acid reacts with 1 mole of sodium hydroxide to produce sodium acetate and water. Moving on to the methodology and result, let's look at how this titration is performed. First, for sample preparation, 10 ml of commercial vinegar is pipetted into a 100 ml volumetric flask, diluted to the mark with distilled water, and shaken well to ensure a homogeneous solution. Next, a 25.0 ml liquid of this diluted vinegar is transferred into a clean conical flask, followed by the addition of 2 to 3 drops of phenolphthalein indicated. We then titrate the sample against a standardized 0.1 m sodium hydroxide solution until it hits the endpoint, where the solution turns into a permanent pale pink color. The titration is repeated to obtain triplicate readings for accuracy. Based on our example data, the average volume of NaOH used was 21.50 ml. By using the formula MAVA equals to MBVD, The molarity of the dilutic vinegar is calculated as 0.086 m. After accounting for the dilution factor of 10, the original molarity is found to be 0.860 m. Finally, converting this into mass percent, the vinegar sample contains 5.16% of weight over volume acetic acid. This successfully proves that the sample complies with standard commercial regulations. That is all from me for vinegar analysis. Thank you.
The analysis is based on acid-base neutralization reaction. A known excess amount of hydrochloric acid is added to the antacid sample. The antacid reacts with the part of the acid, while the remaining hydrochloric acid is left unreacted. This excess acid then titrate with standard sodium hydroxide solution. By determining how much hydrochloric acid remains, we can calculate the amount of acid neutralized by the antacid and evaluate its neutralizing capacity.
The antacid tablet was crushed and reacted with an excess amount of hydrochloric acid. After the reaction was complete, a naphthalene indicator was added. The excess acid was then titrated with sodium hydroxide until a faint pin endpoint was observed. Finally, the neutralizing capacity of an antacid was calculated based on the amount of acid neutralized. Let's look at the importance of an antacid analysis. First, it helps with quality control to ensure the antacid is produced with a good quality. Second, it determines the effectiveness of the product in neutralizing stomach acid. It also ensures the product meets pharmaceutical standards. In addition, antacid analysis helps protect consumer safety by ensuring the product is safe to use. Finally, it supports research and development to improve antacid product in the future.
In this section, I will discuss the determination of acidity in beverages using acid-base titration. The acidity of beverages is an important factor because it affects the taste, quality, stability, and safety of the product. Different beverages contain different types and amounts of acids. For example, fruit juices commonly contain citric acid, while soft drinks often contain phosphoric acid and carbonic acid. To determine the acidity of a beverage, acid-base titration is commonly used. This method allows us to accurately measure the amount of acid present in the sample. As for the theory, the principle behind this analysis is the neutralization reaction between an acid and a base. During the titration, the standard sodium hydroxide solution, or NaOH, is slowly added to the beverage sample. The acid present in the beverage reacts with the NaOH until neutralization is complete. Phenolphthalein is commonly used as the indicator. The endpoint is reached when a faint pink color remains in the solution for about 30 seconds. The amount of NaOH required to reach the endpoint is then used to calculate the acidity of the beverage. The procedure begins by measuring a known volume of the beverage sample and transferring it into a conical flask. A few drops of phenolphthalein indicator are then added. Next, the burette is filled with standard sodium hydroxide solution. The NaOH is slowly added to the sample while continuously swirling the flask. The titration is stopped when a pale pink color appears and remains for approximately 30 seconds. The volume of NaOH used is recorded and used to calculate the acidity of the beverage. And based on these example results, orange juice showed the highest acidity, followed by the cola drinks and sports drink. The differences in acidity are due to the types and concentration of acids present in each beverage. Such information is used for quality control and product formulation. In conclusion, acid-base titration is a simple, accurate, and reliable analytical technique used to determine the concentration of acids or bases in various products. As we have seen, this technique can be applied to vinegar for food quality control, antacids for pharmaceutical quality assurance, and beverages for acidity determination. The results help manufacturers maintain product quality, consistency, and consumer safety. Therefore, acid-base titration remains an important method in food, pharmaceutical, and beverage industries.
I just had to let you know you're. She had me, baby, she